right, in the last video, we identified the growth factor given a single point, just 1 point. So we could identify B if we only knew 1 point. But really, our exponential functions, they have a starting value and a growth factor, okay? And so in order to identify both the starting value and the growth factor, we're actually going to need two points that are on the graph of the function. So we're going to identify both the starting value and the growth factor with 2 points, okay? And so here we have find the exponential function a times b to the t power whose graph passes through the points 3, 5, and 12, 10. We're going to do something very similar to what we did when we just identified the growth factor. We're actually going to plug in these coordinates into this function, where 3 in this case is the t value, and 5, oh, I messed this up. This is supposed to say f of t. Sorry about that, because we're using t as a variable, so we should not have x as a variable. We have t as a variable, so it's f of t is equal to, there we go. Sorry about that. Honest mistake there. So 3 is the t variable, and the f of t variable is 5. Okay, so what we're going to do is we're going to put 3 in here, and we're going to put 5 in here. So we're going to write 5 is equal to a times b to the power of 3. Now we're going to do the same thing over here, where 12 is the t value, and 10 is the f of t value. Okay, so we're going to put a 12 in, we're going to put a 12 in for t, and we're going to put a 10 in for f of t. So we'll do 10 is equal to a times b to the 12th power. What we now have is what's called a system of equations. We have 2 equations and 2 variables. And when you have 2 equations and 2 variables, you can find a solution. Okay? So here's how we're going to do this. For one of these 2, we're going to solve for either A or B, and then we're going to plug that into the other one. Well, it seems to me, so let's bring over 5 is equal to A times B to the 3rd power. And it seems to me that the easiest one to solve for here is A. And the way we can solve for A is to divide by B to the 3rd power. And if I do that over here, B to the 3rd power, here, over on this side, it'll cancel, and what I'll have is that A is equal to 5 over B to the 3rd power. Okay, great. What I'm now going to do is I'm going to take this equation, the second equation, and I'm going to replace the A with what A is equal to, which is 5 over B to the 3rd power. So I'm going to write over here, I'm going to write 10 is equal to, and instead of writing A, I'm going to write what A is equal to, which is 5 over B to the 3rd power. This is called substitution. We're substituting A with what A is equal to. We're replacing A with what A is equal to. And now I have to write the B to the 12th power, B to the 12th power. So what I have here is 10 is equal to A times B to the 12th power, which we already had. But we replaced the A with what A is equal to, 5 over B to the 3rd. Well, we can simplify this now. So we can multiply the B to the 12th power times the numerator, 5. What we now have is 5 times B to the 12th power divided by B to the 3rd power. Well, this can be simplified, okay? We may not have seen this for a while, but I can tell you that, let's say that we had D to the 17th power divided by D to the 5th power. What's going to happen here is we're taking 5 D's out of these 17 D's. If we take 5 out of the 17, that leaves us with 12. So this is equal to D to the 12th. How did we get that? We took the 17 and subtracted 5, and then we had D to the 12th power. Okay? Let me erase that because we don't need to leave that here. That's just an example. Okay? So what's going to happen over here when we do b to the 12th divided by b to the third? Well, 12 divided by 3 is 9. So this is going to become 5b to the 9th power. So we now have 10 is equal to 5b to the 9th power. Okay? Let's bring that over here. 10 is equal to 5b to the 9th power. We're now going to divide by 5 on both sides. Okay? We're going to cancel the 5, and 10 divided by 5 is equal to 2. So we have 2 is equal to b to the 9th power. Well, what we're going to do now is something that we did in the previous video when we identified the growth factor, and we want to get rid of this 9. So what we're going to do is we're going to take this and we're going to do it to the 1/9 power. If we do b to the 1/9 power, or b to the 9th to the 1/9 power, we have to do 2 to the 1/9 power, and we now have a solution for b. b is equal to 2 to the 1/9 power, which we can actually put into a calculator. Okay, we can actually calculate this. Okay, if we key into the calculator 2 to the power of parenthesis 1 divided by 9, key that into a scientific calculator, and let's see what we get. And it looks like we get 1.08. Okay, all right, so we have a solution for b. And now all we have to do is get a solution for a. Now, to get a solution for a, be very careful here, because what we're going to do is we're going to plug in b. We're going to plug in a number for b to the 3rd power. But be very careful here, because we do not want to put in 1.08. That's an approximated value. We actually want to put in 2 to the 1/9 power. So now a is going to be equal to 5 over, and then b is 2 to the 1/9 power to the power of 3. Now, 1/9 to the power of 3, or 2 to the 1/9 to the power of 3, this is the same thing as 5 over 2. Well, 3 times 1/9 is 3/9, and 3/9 is the same thing as 1/3. So we have 5 over 2 to the 1/3 power. This we can key into a calculator as, so a is equal to 5. Then we hit the divided by button. Okay. Then we can do 2 to the power of parenthesis 1 over 3. Okay. So let's do that in the calculator. And I get a is equal to 3.969, or approximately equal to 969. Okay? And so we have a solution for a, and we have a solution for b. And so now we could say that f of x is equal to 3.969 times 1.08, or it's not f of x, it's f of t, to the t power. Okay? And so we found a solution for a and b. Let's do another example. All right, so let's look at this one. It says find the exponential function f of x is equal to c times a to the x power. Now, don't get confused by this. In this case, they're just saying the starting value is represented by the letter c, and then the growth factor is represented by the letter a. So this is the a, and this is the b. We can solve for them, but we're using capital C and lowercase a. It's okay. This is the starting value, and this is the growth factor. Okay, so find the exponential function. So we got to find c and we have to find a, and it says whose graph is shown. Well, here's the graph right here, and all we really care about from the graph is the points, 248 and 4768. Okay, so it passes through the points 248 and the point 4768. So we're going to do this exactly like we did the last example. Okay, we're going to put the 2 in for x, and the f of x is going to be 48. Okay, so we're going to write our first example, or our first one is going to be 48 is equal to c times a to the power of 2. And then we're going to put in a 4 for x, and then a 768 for f of x. So we're going to do 768 is equal to c times a to the 4th power. Okay. So we're gonna solve for c first. So we're gonna do 48 is equal to c times a squared. So we're going to divide by a squared on both sides, a squared, and we're going to get c is equal to 48 over a squared. Okay. All right, now that we have c, we're going to take this 48 over a squared, and we're going to put it in for c on this other one. So we're going to do 768 is equal to, in place of c, we're going to put 48 over a squared, just like we did in the last example, times a to the 4th power. Now we're going to multiply the a to the 4th times the 48. We're going to put the a to the 4th in the numerator with the 48. Okay, so we get 768 is equal to 48 a to the 4th power over a squared. Well, the a fourth over a squared, we can cancel the a squared by taking 2 out of the a to the 4th. So this a to the 4th will become a squared. So this will become 48a squared. Okay, so 768 is equal to 48a squared. 768 is equal to 48a squared. So now we're going to divide by 48 on both sides. Divide by 48. Okay, and we wind up with 16 is equal to a squared. Well, that's easy. Now we just need to know, well, what a to the 2nd power is equal to 16. Well, we know that that's 4, so a must equal 4 because 4 squared equals 16. Another way we could do this is we could do a squared like we did in the last one to the 1/2 power and do 16 to the 1/2 power. And now when we do 16 to the 1/2 power in a calculator, we're going to get 4 because this means square root. The square root of 16 is 4, and that means a must be equal to 4. Now that we know what a is equal to, we can just plug that in here and find out what c is equal to. So c is equal to 48 divided by 4 squared. Well, we know that 4 squared is equal to 16, so we have 48 divided by 16, and 48 divided by 16 is equal to 3. And therefore, a is equal to 4, c is equal to 3, and our equation f of x is going to be equal to 3 times 4 to the x power. Let's do one more example. All right, this last one, we want to find the equation of an exponential function, and the graph passes through 2 points, 322 and 24.6. Okay, now I want to point something out. Our x value is smaller than 24, or our first one, 3 is less than 24, but look, we are going down from 22 down to 6, so this must be a decay function because our output values are going down from 22. As our x values go up, our y values go down. So this is definitely a decay function. And that means that our b is actually going to be less than 1. It's going to be either a decimal less than 1 or it's going to be a fraction that's less than 1. Okay? All right, so let's go ahead and set this up. We're going to put a 3 in for x, and we're going to put a 22 in for x, f of x. Okay? So we'll have 22 is equal to ab to the 3rd power. Then we're going to put 24 in for x and 6 in for f of x. And we'll have 6 is equal to a b to the 24th power. Okay? So we'll take this first one here and we're going to solve for a. So we'll have 22 is equal to a times b to the 3rd power. We'll divide by b to the 3rd power on both sides. Okay? And we wind up with a is equal to, oops, sorry, I shouldn't have done that. A is equal to 22 over b to the 3rd power. Okay? So we're going to take this 22 over b to the 3rd power. We're going to put it in for a right here. We'll have 6 is equal to 22 over b to the 3rd power times b to the 24th power. Now we're going to take our b to the 24th and put it in the numerator with the 22. And we'll have 6 is equal to 22 b to the 24th power over b to the third power. b to the 24th divided by b to the third. We're going to do 24 minus 3, and that gives us 21. So we get 22b to the 21 power. Okay? So we have 6 is equal to 22 times b to the 21 power. Divide by 22 on both sides. And 6 over 22 can actually be reduced, but we'll leave it as 6 over 22 for now. 6 over 22 is equal to b to the 21st power. Now we can do b to the 21st to the 1 over 21 power. We'll do the same thing over here, 6 over 22 to the 1 over 21 power. And let's do this in a calculator now. We'll have b is equal to, we're going to key in 6 over 22, we're going to key in 6 over 22 to the 1 over 21 power, okay? Now this is going to look a little funky in the calculator, but what I would do is parenthesis 6 divided by 22 in the calculator, close parenthesis, raise it to the power of 1 divided by 21. If you key it in like this, you should get the right answer. I'll be right back. And what I get is I get 0.94 as my answer. And so B is approximately equal to 0.94. Okay? All right. Now we're going to come up here and we're going to find A. So A is equal to 22 over b to the third power. Now be careful here. What I want to do is I want to put in 6 over 22, okay, to the 1 over 21 power, okay, and then I'm going to raise that to the third power. Well, 3 times 1 over 21, we could say that is 22 over, this is going to be 3 over 21, which is 1/7. So this is going to become 6 over 22 to the 1/7 power. Okay? So I'm going to go ahead and key this whole thing in the calculator, and I'll be back in just a minute. And what I get for this is 26.487. Okay? And so my function, f of x, is going to be 26.487 times 0.94 to the power of x. We can test this if we key in a 3. Let's see what we get. So what I'm going to do is I'm going to put a 3 in for x, and I'm going to see if I get 22. And sure enough, I get 21.999, which is approximately 22. So this is correct, okay? And this is how we take 2 points and identify the starting value and the growth factor of an exponential function.